So, a very good evening, everyone. Myself, Shivashish Dobal, and I am a PhD scholar from AIMS Rishikesh, and I will be moderating today's session. So, first of all, I warmly welcome you all to the hands-on workshop titled Statistics Made Easy, Basic to Advanced Biostatistical Online SPSS Series Season 2. And today marks the day 3 of the workshops, and the topics to be covered today are displaying on your computer screens. You can see that. So without further delay, I would like to welcome Dr. Ashok sir to kindly begin the session. Over to you, sir.
Thank you, Shivashish. Thank you. And good evening, all participants. So, as I told you that we will repeat yesterday's some topics, and then after that we will discuss about parametric test. Okay. So I'm going to share my screen. This. So Shivashish sir, my screen is visible?
Yes, sir, it is visible, sir.
Okay, thank you.
Okay.
So we will discuss about the normalcy testing of quantitative data. It's just a repetition. How to calculate mean, HD, median, IQR, minimum and maximum of quantitative data. Frequency and percentage of qualitative or categorical data, coding and decoding of variable in the SPSS, and after that, parametric test. If quantitative data are normally distributed, then we use parametric test for comparison of their means. Okay. So if there are two groups, we use t-test. If pre and post design, before and after design, we use paired t-test. And if there are more than two groups and we want to compare means of independent variables, then we use one-way ANOVA, okay, with the post hoc analysis for multiple comparisons. So first of all, we will discuss about independent and dependent variables. And what do you mean by variables? We have already discussed. So examples: effect of diet and yoga on hemoglobin. Okay, so in this, independent variable is diet and yoga, and dependent variable is hemoglobin level. And second example, you can think and you can answer: effect of divergent therapy on pain level. So in this, independent variable is and dependent variable is, you have to give answer. Okay, you can give here answer, or you can give in WhatsApp group. You have to think and you have to give answer. And third, effect of this SPSS workshop on statistical knowledge and practice. So what is independent variable in this, and what is dependent variable in this? So you have to think and you have to give answer, okay, in this chat box or even WhatsApp group. So what is it? It's coming. Okay, that is a parametric test and non-parametric test. Okay, good. Parametric versus non-parametric test. What test we have to use? Parametric is a robust and powerful test to test a hypothesis, the relationship between independent and dependent variable. Non-parametric test is less powerful. Okay. So we have to check normalcy, and after that, if quantitative data is normally distributed, we have to use parametric test. And if quantitative data is not normally distributed, we have to use non-parametric test. So these are some conditions, okay? So in condition 1, if independent variable is two independent groups, okay, or categorical variable. For example, treatment group, control group, okay, male group, female group, okay, mortality, not mortality, improvement, non-improvement. So there are two independent group, and dependent variable is here quantitative in nature, okay. For example, age, height, weight, systolic BP, HB, okay, and score, anxiety score, depression score, etc. So if this quantitative variable is normally distributed, and we have to compare between two groups, you have to remember two groups, okay, independent groups. For example, male and female, these two groups are independent group, okay. So we have to use independent or unpaired t-test to compare the mean score between two independent group of that quantitative variable or dependent variable. If the quantitative variable is not normally distributed, so in place of independent t-test, we have to use a Mann-Whitney u-test. Okay. Next, if same group or one group before and after design, pre and post design, for example, there is hemoglobin level, and in one group, 100 patients, we have to check hemoglobin level pre-experiment. Okay, after that, we give experiment, for example, diet and yoga. And after this experiment, we will check again hemoglobin, same patients, again hemoglobin, okay. So it is called same group, one group before and after design, pre and post design. And dependent variable is quantitative, that is a hemoglobin level, that is a systolic BP level, that is a weight, height, score, you can say, okay, creatinine level in CKD patients. And we are giving like yoga therapy. So before creatinine level, then yoga, diet and yoga, and after creatinine level. If you want to compare this mean comparison, and this creatinine level or hemoglobin or score is normally distributed, we have to use, or we should use dependent or paired t-test. Otherwise, Wilcoxon signed rank test, its counterpart. Okay, Wilcoxon signed rank test. It is a full form of like this. Please remember this, Wilcoxon signed rank test. Sometimes only Wilcoxon rank test is over there. You can see in some literature. So that Wilcoxon rank test is a Mann-Whitney u-test for, and it is for two independent groups. But for same group before and after, if data is not normally distributed, then we have to use Wilcoxon signed rank test. Now, third condition, more than two independent group. For example, one control group, number two group is only diet therapy. Number third group is diet and yoga therapy. 100% in control group, 100% in diet group, 100% in diet and yoga group. You can imagine like another scenario, okay? Then dependent variable is quantitative. For example, HB, score, height, weight, creatinine, whatever. We have to use, if this quantitative variable is normally distributed, we have to use one-way ANOVA, analysis of variance test. Okay. If this quantitative variable is not normally distributed, we should go for Kruskal-Wallis test. It's counterpart of one-way ANOVA. This is counterpart of one-way ANOVA. Now, fourth condition, if independent variable is quantitative, for example, height, and dependent variable is also quantitative, for example, weight, and height and weight both are quantitative in nature. So for this, we have to use Pearson correlation coefficient R if these both are normally distributed. Otherwise, we have to use this Spearman's rank correlation coefficient. It's called rho, RHO, rho. Okay. So if both quantitative variable are normally distributed, then we have to use. For example, number of hours we are studying and number of marks we are getting. So number of hours is independent variable and that is quantitative nature, and dependent variable is marks we are getting in exam. This is also quantitative in nature. If both are normally distributed, we should go for Pearson correlation coefficient. Otherwise, we have to use Spearman's rank correlation coefficient. Now, fourth condition, one group only, single group, and we have baseline. This is a pre. This is after intervention 1 month, 3 months, and 6 months. It means there are repeated measures or multiple follow-up. Only single group. So what we are doing, we are assessing pre-HB, and after that, after intervention, we are assessing again HB at 1 month and at 3 months or at 6 months or at 1 year. If this is scenario, okay, in our case, and HB is, we know that it is a quantitative variable, dependent variable is quantitative variable, scenario is one group, baseline 1 month, 3 months, 6 months means repeated measures or multiple follow-up. So if this quantitative variable is normally distributed, we have to use repeated measures analysis of variance, RM ANOVA. Otherwise, we have to use Friedman's test. It's a counterpart. And there are many more conditions we will discuss tomorrow. So this is main slide we have to remember. Or this is mnemonic I prepared for parametric test. You can remember it. Parametric test means independent unpaired t-test, dependent paired t-test, one-way ANOVA, Pearson correlation or repeated measure ANOVA, and quantitative variable, dependent variable, you can see all are quantitative variable in these conditions, okay? In these conditions, you can see quantitative variable, dependent variable is quantitative in nature. And independent variable is changing. Two groups, same group, pre-post, more than two independent group, quantitative, okay, in nature, and one group, pre-post, post 1, post 2, post 3, repeated measures. So remember this is a mnemonic you can use. I do play with RIMA. I means independent t-test. D means dependent t-test. O means one-way ANOVA. P means Pearson correlation coefficient, and RIMA means repeated measures ANOVA. So you can remember this. Okay. Now next, mnemonic for counterpart of parametric test. So these are the non-parametric counterpart of parametric test means non-parametric test. Mann-Whitney test, Wilcoxon test, Kruskal-Wallis test, Spearman rank correlation, Friedman. For independent t-test, counterpart is Mann-Whitney. For dependent, it is Wilcoxon. For one-way ANOVA, it is Kruskal-Wallis. For Pearson correlation, it's a Spearman. For repeated measure or RM ANOVA, it's a Friedman test. So for this, I have prepared one mnemonic, Mawali kahin ka sirfira. Okay. It is given in English or in Hindi. You can see Mawali kahin ka sirfira. And again, if you want to learn only in English, that is a Mr. Wilcoxon kindly see fried rice. So what do you mean by this? Mawali kahin ka? It means for independent t-test, that is a Mann-Whitney u-test, it is ma, okay, Mawali ma. And then it is Mr. M, okay? And this is also in ma, okay? So for dependent t-test, it is Wilcoxon signed rank test. You can see W, ma, wa, okay, wa. And then for one-way ANOVA, it is Kruskal-Wallis test, kahin ka, okay? And then for Pearson correlation, it's a Spearman correlation coefficient. You can say Sir-Fira S, okay? And then for repeated measure ANOVA, it's a Friedman test. You can say Fira F. So you can remember this Mawali kahin ka Sir-Fira or Mr. Wilcoxon kindly see fried rice. Okay, M is Man Whitney, W Wilcoxon means Wilcoxon, K means Kruskal valleys, S means Spearman, or Fry means Friedman test. Now let's have fun with SPSS. So we will do all these things, and there are some conditions. So let's have one example, a randomized clinical trial, controlled trial to assess the effect of diet and yoga on hemoglobin level of cardiac patients, for example. And I have shared one Excel sheet with you, you can see. So primary objective of this research to assess the effect of diet and yoga on hemoglobin level of cardiac patients. There are some secondary objective to assess the effect of diet and yoga on LDL and HDL level also, and to assess the effect of diet and yoga on patients' survival, mortality survival. On methodology, we randomly selected 300 patients, large sample size, 100 in each group, and we did 3 months follow-up. Okay, 1 month and 3 months, I think. 1 month and 3 months follow-up. Suppose 3 months baseline and 3 month follow-up. Okay. And please understand about between group and within group analysis also. So is there any significant difference of age between males and females? So males and females are independent groups, okay? Two independent groups, that is a between, okay? And there is age. Age is a quantitative variable. This is our dependent variable, age. So we have to remember which test we have to use. Please, you can refer that slide, and you have to think and you have to use this test. If data is not normally distributed, we have to use this test. If data is not normally distributed, we have to use Mawali kahin ka, okay, sirfira, this test, okay. And it is called between groups. Is there any significant difference in hemoglobin level at 3 months between males and females? Also, there is independent group, two independent group, males and females, and HB level at 3 months. So this is HB level is your dependent variable, and males and females, that is a gender variable, is our independent variable. You have to think. Is there any significant change in HB level from baseline to 3 months follow-up in treatment groups and in control group? Okay. So it is called a within group because we want to see difference or comparison from baseline to 3 month within group. Within group, okay? That in treatment groups and in control group. And in there any significant change in HDL and LDL level from baseline to 3 months follow-up in treatment groups and in control groups, it is also within group analysis. So we have to like remember this, what do you mean by between groups and what do you mean by within groups? Within groups means baseline to 1 follow-up to versus 3 month follow-up versus 6 month follow-up, and between groups means difference between case or control, intervention and experiment, male and female, okay? According to religion, there are 4 groups, religion 5 group. So if we want to like compare HB level according to religion, so HB level is quantitative variable or dependent variable. Religion is our independent variable. So it has more than 4 category or 3 category, more than 2 categories. So we have to use, and it is called between group comparison. Okay. So let's start. We have to open our Excel sheet first, and we have to check for any logistic errors. And if there is, and we have to see this Excel sheet is following 7 rules or not. Okay. So click, open your Excel sheet. So this is our Excel sheet we use today. So we have name. Okay. First rule is variable name must be in first row of Excel sheet. So we can see it's a first row and all variable name in a first row. Okay, very good. Then from second row, there must be observations and data entry. Okay, observation and data. We can see here. Oh, very good. There is no. Okay. Okay. Then first column must be serial number. So what we see, okay, first column is a name. It's not a serial number. So what you have to do, you have to bring your cursor. You can see here on first column A, and you have to click and select this column like this. Then you have to click right click of your mouse pad, right click, and then you have to click insert. Then there are how many patients we can see? There are, okay, there are around 300 something patient. Very good. 100 in each group, 3 groups. Okay. And these are this is group, control group, then diet group. Okay. One diet group, and next diet and yoga group. There are 3 groups. Okay. So we have to enter here serial number. So click here. First on first row, we have to click here, and we have to type S underscore number. Then what we have to do? We have to click here, and then we have to enter 1, and then 2, and if we enter 3, 4, 5, 6, it will take time around 15 minutes, 10 to 15 minutes. So shortcut is we have to type 1 and 2, then we have to click on 1, then press shift and down arrow, and there is one, you can see here, when I bring my cursor from here to this corner, okay, you can see there is a change. Then you have to, what you have to do, you have to drag it, and you will get all serial number within seconds, and there are 300 patients. Very good. So it's okay. Then what you can see here, if I want to enter data, suppose if I want to enter data in like here, I want to enter data. For example, I want to enter data and 301, 302, 304 patients, or I have to enter data up to 500 patients. So you can see here, when I bring this Excel sheet here, so there is, and I can see here, it's a serial number, this is name, this is age, this is group, and what is it? And what these are the, and what this is, I cannot remember, because we can see here in above, there is no variable name I can see. Okay, so what are these? I cannot remember this. Okay, so for this, what I have to do, please see this. It is very beautiful function, and please use this. So what I have to do, this is name and this is age. So please, below this first row and nearby this age, you have to click this. Okay, near to, after this name, okay, name column, and below this first row, you have to click here. And then what you have to do, you have to go in view. Okay, this is view. You can see here above this, insert, page layout, formula, data, review, and view. You have to click this view, and there is one button. This is a freeze panes. Please remember, I cannot repeat it, so please remember this view, and then freeze pane. Click freeze pane, and then please click this freeze panes. Okay, click here. Then you can see here, and now you can see there is one dark line here below this variable name, and there is one dark line here, you can see, after this column. And when I want to enter data of 300 patient, now I can enter easily, because when I bring this Excel sheet down, I can easily visible the variable names. So no problem for me. And if I want to enter data here, after this, I can see the name of each patient. So I can easily enter data in this Excel sheet. Okay. So it is very beautiful function of this. So I have like I have removed logistic and cosmetic errors from here. Then I have to save it. So what I have to do, this is button, we can see here, right, left top corner, there is a save, or you can type Control and S. And then you can remove, you can cross, you can close it, because we have to now open SPSS. And I'll tell you how to import Excel sheet into SPSS again. And every day I will tell you, no problem. So close it, open our SPSS. Okay, this is SPSS. So please open your SPSS. It will take some time. It will take some time, no issue. So freeze pen, please remember, okay? You can write down till you will get recordings. You can write down these steps. These are very important steps when we are entering data in Excel sheet. Okay. I think it's taking. Okay, it's opening. Sometimes if there is a network issue, it's like a problem in opening of SPSS. It may happen. Okay. Although it's taking time, or it's coming. I have to wait. Okay, it's opening. This is Excel sheet, SPSS sheet, new sheet. Sivasis, my screen is visible? Sivasis?
Yes, sir, it is visible, sir.
Okay, okay. Now I'm going to tell you how to import Excel sheet into SPSS sheet in very easy way. Okay, so for this, what you have to do, you have to first click this minimize button here. You can see here. Yeah, okay, this button is a restore down, something like that. This button, right side upper corner near to cross, and between minimize and cross button there is a restore down. You have to click this. You have to make your SPSS sheet like this. Okay, very good. You have to make. Then what you have to do, you have to click where is your Excel sheet. My Excel sheet is in SPSS session. This is SPSS session. Please click this. Okay, it's opened. Now what you have to do, you have to make double screen. Okay, so what you have to do, you have to click here upper right corner. This is a cross, this is minimize, and this is a restore down, something like that. You have to click this. You have to make arrangement according to this. Okay, it's a very easy way. I'm going to explain you how to import data from Excel to SPSS. It's very easy. Okay, so what I have to do, I have to click this because I have to enter this. I know which Excel sheet I have to enter. So I have to click this, and then what, I have to drag this from here to here. Okay, I have done my work. It's opened. So no need to worry. It's opened. This dialog box will come. Okay, again, you have to make SPSS, and where is our sheet? We have to make like this here. And then what I have to do, I have to click this, and I have to drag this from here to here. Okay, this is, you can see there is a move arrow, and then I have to remove from my pad. This will come. And I have to remember where is my Excel sheet. I think one participant asked, how can I choose? So I have to click, this is a worksheet, sheet 1. Okay, so I know that there are 300 patients something. Then I have to click here. There are other sheets also, but I should know where is my data, actual data sheet, main data. So this is my data I have. I don't have in this, and I don't have in this. So click here. Then you have to remember this, that all these first 3 boxes must be checked. Okay, read variable names from list, first row of data, main thing, and these things. So first 3 checks you have to do. Okay, and then you have to click OK. You can see changes in my SPSS sheet. I have to wait for some time, I think. Oh, it's CAM. Very good. Very good. It's CAM. Okay. So I have to see here. Oh, everything. Yes, I can see my data. Any variable is missing or everything is fine. I can scroll down side by side. I can see. I have to see how many patients entered. And we can see here 300 patients. But after that, there are some points you can see here. There are little bit points, small points, dot you can see. But there is no data. I can like scroll. We have to see it. And there must be note. Okay, sorry. So I can use this we can, you can see here, there is a below, there is a, we can break it like this. So there are no data there. These are the black dots, small in these cells. Okay, so I should remove it. So what I have to do, I have to click this here. I have to click here. Please don't click here, and here. I have to click this 301 and then shift and down arrow. And what after that I have to bring my cursor from here to here. Then I can remove it. Otherwise, what happened if I keep my cursor here and then click right, okay, from right click on your mouse or pad. So what happened? This disappeared. So what I have to do, I have to click here, then shift and down again, and then bring my cursor here, here, okay, then click right click and then clear. 300, it's very good. I like intentionally, I did not enter these data, okay, intentionally. So these are blank, so I can, okay, this is group, this is gender, okay, this is age. You can see in age, there are some missing values. In gender, there are some missing values. So please remember, you have to enter data first, complete data. Okay, try your best to fill these values. So you have to see your records again. You have to talk these patients. You have to talk these patients caregivers. What is age? And for gender, we can like see. For example, this is missing and this is Jaivati. So it's a female. So I have to remember what code I have to given. For example, this is there are some, I think there is some mistakes in, because this is a hypothetical data. So I have given 1 for male and 0 for female, but the name of, because this is a hypothetical, so these are not correct. Okay, so for like this. Okay, so just remember. So what I have to do first, I have to check normalcy. Okay, so for quantitative variables, remember, for quantitative, so what I have to do, I have to click analyze, then descriptive, and then explore. Okay, click explore. Then I have to click which variable I have to check normalcy. I have to click this variable. This is a dialog box, explore will come, and then I have to click this. And then from here to here, I will bring this age into this dependent list. Click here, okay? Click age, that variable, and this is arrow, click here. After that, this is sex is not quantitative variable, group is not quantitative variable, and duration is quantitative variable. So I have to click this and then bring this here. I know that hypertension, diabetes, smoking, these are not quantitative, but here height, weight, BMI, all are quantitative. I can select these like in one shot. So what I have to do, I have to click shift and then down arrow and then bring these. Okay. For like for demo, I'll use on these only these 6 variables. Then what I have to do, I have to click plot, and I have to use this histogram also, and then normality plot with test. I have to click here and then in explore plot and then click continue. Please don't like do anything here in display. You have to just click OK. So in results, we will check it. These are normal distributed or not. Already I have given demo on yesterday. So this is result. I can see, first you have to see here in age there are, we know that like total 300 patients, okay, 300, n is equal to 300, but 34 are missing, okay. So age has 266 observation, duration 266, hyper this is height, weight, BMI, and heart rate 266, 266, 26. Might be it is okay, no problem. Then we have to see this mean HD. You can see HD here, minimum and maximum interquartile range, and we have to see skewness is kurtosis here. So if skewness and kurtosis value between -2 to +2, it means this variable is normally distributed. For duration of illness, we have to see mean, and this is HT here, and this is minimum, maximum, and this is skewness and kurtosis beyond +2. So it's not normally distributed. Just looking skewness, kurtosis. Like height, weight, and BMI, you have to see, and heart rate for, okay. Then we have to see normalcy test for normality. So we have to go for Shapiro-Wilk test. I recommend Shapiro-Wilk test. If you want to go for Kolmogorov, it's okay, no problem. But I recommend Shapiro-Wilk test. And for Shapiro-Wilk test, this is SIG is a p-value. Please remember, if the data is normally distributed, when Shapiro-Wilk test is p-value is greater than 0.05, or Kolmogorov-Smirnov p-value, this is p-value greater than 0.05, okay. For duration of illness and height, weight, BMI, and heart rate, we can see all are not normally distributed by seeing this Shapiro-Wilk and Kolmogorov-Smirnov by both tests. All are not normally distributed. Now we can see here histogram. I think it's approximately normally distributed histogram. Then we have to see this QQ plot. Oh, it's because all the variable must be on or nearby this line, normality line, okay, QQ line. So normally distributed. I can say looking histogram and kurtosis and skewness and QQ plot, this age is approximately normally distributed. Now see this histogram for duration of illness. Oh, it's totally skewed. It's a right side tail. It's a positive skewness. Okay, and then I can see here totally deviate from this QQ normal line. So I can say duration of illness is not normally distributed. So for age, I can go for parametric test, and for duration of illness, I should go for non-parametric test. If there are two groups, I use for age is independent t-test, and for duration of illness, counterpart Mawali Kahinka, that is a Mann-Whitney U test. Okay, so you please see according to this. But what the problem here, I have to see whether I have these missing value in height, weight, BMI, or heart rate also, or age or duration illness. So what I have to do, I have to open my data sheet. Okay, so from where I have to click, this is the, you can see here, this is a star. So go to data, you can click here below this analyze, you can click here, you can see your data sheet. Then I will check here. Okay, in age there are missing values. Okay, in duration of illness there is no missing value. So how come it's possible? In age there are missing value, I can understand, but in duration of illness there is no missing value. After that, for height, weight, BMI, heart rate, oh, there is no missing value, but I'm getting over there are missing value. So what's the problem? The problem we have to rectify. So what is problem and how we rectify? Okay, let's again do non-parametric normalcy test, and we will correct this mistake. How? Click analyze, descriptive statistics, explore, click explore, then all the things are okay, but you have to click this option button here, click here, and this is option button, explore option, and what you have to change here for missing value, you have to click exclude cases pairwise. For in case of missing values, please click here and then click continue and then click OK. Okay, so what the difference between these two things? Please see, this is like valid case, but you can see here in age the valid case is 2 to 6 and missing is 34. It's okay. But for duration, height, height, weight, BMI, there is 300 we are analyzing. There is no missing case. So this analysis normalcy test is valid. So please ignore that analysis and we have to follow this. So you can see it's QQ plot, skewness, kurtosis, and this p value Shapiro will you can see, and if there is changes you can note down over there. Okay, but we have to follow this test. Now next, how to calculate mean, median, mode, interquartile range for quantitative data. Okay, so for this, no need to go in data variable or data. If you want to go in data, you can click this star button below this analysis. You can click. Otherwise, directly you can click analyze. Okay, then descriptive statistics. It is analyze is very familiar, or I think you use most of the time. Then descriptive you use most of the time. Okay, analyze, descriptive, and frequency. So you have to click this, and this frequency dialog box will come here. Then what you have to do, you can increase it. Then I told you that I can calculate mean, median, standard deviation, IQR, minimum, maximum for only quantitative variable. And you know very well what are the quantitative variables. So what you have to do, you have to click this age, and this I have to bring this age from here to here. So I have to click this arrow. Otherwise, I can drag it from here to here. It's very easy. So, okay, next, duration of illness. I have to click this. I can drag from here to here. Then for height, weight, BMI, click here, shift and down arrow, and then I can bring from here to here. Okay. For same thing, I'll do here. Okay, no issue. For this, I have to click this statistics now and click here. Then I have to click mean, median, click quartile. You can see here percentile value. Then you can click standard deviation, minimum, maximum. Again, kurtosis or skewness you want, you can click here, no problem. Variance, you can click here. If you want percentiles, you can click, no issue. So we have to select all these and then can continue. Then if I want to make charts, so I can click here, charts. I want this histogram because bar chart and pie charts for categorical qualitative variable, histogram for quantitative variable. So what I have to do, I have to click this histogram and then show normal curve on histogram. So click here also, then click continue. And please remember, no need to do like for quantitative variable display frequency table, no need. So please declick it, deselect it, okay? Uncheck it. Then click OK. So what you will get? You will get age, duration of illness, height, weight, BMI, heart rate. You can see valid cases here. You can see missing cases here. Then you can see mean, median, standard deviation, variance. Variance is square of the standard deviation. You can calculate, okay? You can calculate, you can do square of this, you can get variance of this. You can see skewness, you can see kurtosis, you can see minimum and maximum age, and you can see percentiles. In percentiles, you can see this is 25th percentile, it is first quartile. 50th percentile, this is a second quartile. 75th percentile, this is a third quartile. This 50th quartile is also called median. So you can see here median is 57 and this is 50th percentile is also 57, same. You can see in these also, okay? And this is interquartile range 46 to 62. So what is like median of this age? This is 57. And what is IQR? 46 days 62. You have to write down over there. For like duration of illness, height, weight, BMI, heart rate, you can see here. Okay, all the things. Then you can see histogram with curve line, normal curve line. Oh, it's looking like a bell-shaped curve. Okay, it means it's a normally distributed. But you can see duration of illness. This is a normal curve line. It's a deviated. It's like tail is towards positive hand or right hand. It's a right skewness or positive skewness. We can see height. Okay, it's looking normally distributed. Weight is also looking normally distributed. And BMI is also looking, but something tail is here. So we can see according to this. Now, last thing I want to, because t-test, parametric test, we can do tomorrow. There is no problem. But these things are basic for us to learn. I can do tomorrow t-test, pair t-test, independent t-test, pair t-test, and ANOVA. And after that, we can go for a non-parametric test, counterpart of these. We can do tomorrow. There is no problem. But this is main thing I have to explain again. Now I have to do coding and decoding, and I have to calculate frequency and percentage. So coding and decoding, we have to remember, we can do coding and decoding for quantitative or qualitative variable. We have to remember. Okay. So coding and decoding, coding and code and decode, we can, or category for qualitative variable and categorical variable. So what are the categorical variable in our sheet? I have to click this data view. Below this analyze, there is one button of star. I can click here. Otherwise, number 2, I can bring this taskbar cursor, bring your cursor on taskbar, and this is untitled 2. I can click here. This data view will come. Okay. Then what I have to see, I have to do for categorical variable. For group is also categorical variable. There are 3 groups. Sex is categorical variable. Hypertension, diabetes, smoking, alcohol. Yes, no, yes, no, yes, no. Patient having hypertension or not? Yes, no. Diabetes, patient is having diabetes or not diabetes? I have to enter yes, no. Yes means 1, no means 0. Okay. I have to enter according to this. So for this, I have to calculate frequency and percentage. For this, what I have to do, I have to again go in analysis, click descriptive, click frequency. Same steps I have to follow. Okay, click here. Then I want to calculate frequency and percentage. No need to calculate this mean median. So what I have to do, I have to click this reset button. You can see here in frequency there is below okay, paste and reset. I have to click reset. You can see changes in variable box. All the things reset. Okay. So for group, I have to, because it is a categorical variable, I have to click this. I can bring from here to here. For gender, I have to click, I have to calculate frequency and percentage. For hypertension, diabetes, smoking, alcohol. So what I have to do, I have to click on hypertension, then shift down arrow and up to this. Height, weight is a quantitative variable. There is no need of this frequency and percentage. Okay. If you need frequency percentage of this age and height and weight, you can calculate according to your guide and co-guide, or research purpose or publication, you can calculate. So click here. All these qualitative, only qualitative variable came here. So what you have to do, you have to please check, you have to click this display frequency table. If you didn't, or if you don't check this, so what happened, you can see here. Click here, don't check. Then what happened, you can see, okay, there is no any calculations here. There is no any frequency and percentage. So what we have to do, again, I have to go analysis, descriptive, frequency, this dialog box. Then I have to click display frequency table. Then I have to click OK. You can see changes here. This is group, this is control group, diet and yoga and diet group. Okay. Frequency, this is 100%, 100%, N, or this is a percentage, 33.3, 33.3. Please remember, always take valid percentage. Always take valid percentage. Why? You can see here below this gender, you can see the benefit of taking valid percentage, because it's a validity. Okay. It's a correct assessment. Okay. So for this is a 0 and 1. I don't know what is 0, what is 1. Okay, so I have to I have to decode it also. So this is 0. I don't know what is 0 here, and this is 1. I don't know what is 1. Suppose 0 is like for female and 1 is for male. So 84 is female out of 300, not 300, because 25 are missing. So only 275 out of 275, 84 are females. Okay, and 1 is male. So out of 275, 191 are males. But when we take this percentage, this is out of 300. But it is not good. It is not correct, because we have only 275 observations in gender. So I have to take valid percentage, and this valid percentage is out of 275. And we can see the difference into in the percentage we can see. So please always take valid percentage. Please never take this percentage. Please be like make it habit. Okay, then hypertension we can see here. In hypertension, I have given only 0, 1 and 11. What is 11? I didn't give 11. I have given only 0 or 1. 0 means absent, 1 is present. Okay, yes, no and yes. 0 is no, 1 is yes, but what is 11? It means there is mistake in data entry. I have to correct it. Okay, in diabetes we can see this is 0 and 1. Oh, diabetes is very good. I can take in this case you can see valid percentage or percentage are same, because there is no missing value. In case of missing value, always take valid percentage. Okay, in smoking again there are 11. You can see 11 I didn't enter. I know that I didn't enter this 11. So there is some mistake. Alcohol I can see my data. I can correct my data entry after seeing these results. So what I have to do, I have to click this hypertension. I have to make changes in hypertension. Okay, so what I have to do, I have to go in data view. I have to check where is hypertension. Oh, here hypertension. Then I have to see one by one where is 11. I have, oh, this is 11. I have to click. I have to correct it. Wait 1 minute. Then I have to see where is 11. Sometimes 11 goes, there is a, okay. So there is problem to like drag it. Sometimes 1 and 2 may be missing in this, like when we are searching. So there is use of serial number. So what's the use of serial number? Please see here. What you have to do, you have to click this hypertension. Okay, you have to select this hypertension. So what you have to do, you have to click here. Your cursor here should be, and click here. This column selected. Then click right. Okay, and then click sort ascending and sort descending. But when you click sort ascending and sort descending, so what happened? These names or serial number will change automatically according to hypertension columns ascending or descending. Because I have entered 11, so when I do ascending, so first 0 will come, then 1, and then 11. Okay, if I click on sort descending, it means 11 come first, then 1 and then 0. So I can easily rectify. So please click sort descending here. Click here. You can see, okay, in hypertension 11 came here. I can correct it. How many 11 or maybe other missing data I can correct using this technique. So 1, 1, 1. Oh, everything is fine. Okay, then I can click once again. I can click here and then sort ascending. Or sort ascending, it's a 0. It means everything is fine. Okay, then what happened here? You can see here in serial number and name, there is changes in name. But I can rectify it. I can correct it. How I can correct it? I can correct it. Same SPSS sheet I can make. Please click serial number here. Then right click and then sort ascending. So this is a previous my SPSS sheet according to serial number. So you can see if there is no serial number, we cannot do this. And we cannot do, we have to take, like we can do, but it will take more time. We don't have time. So this is a shortcut method using this serial number. I can, for example, next, I can go for smoking. Okay, diabetes I can check. So click here, right click and descending. Oh, it's okay, no issue. For smoking, click here, right click and descending. Oh, there are four something wrong entry. One. Okay, it's okay. Sometimes double one I could type. I think I know. Okay, so I can check it. Alcohol, right click, descending. Oh, it's okay. Obesity, right click, and oh, very good. Then what we have to do? Come here, click serial number, right click, and sort ascending. Oh, previous data sheet I got. So there is no problem. I can see. So first I want to save. Okay. Next is coding, because I want to like demo on how to code male and female 0 to 1. So what I have to do, because in sex, this is sex 0 and 1, I want to code. Okay. So what I have to do, I have to go in variable view here. Click here. There is sex, and please see, this is a sex. Okay. And then you can go here. This is value. Please see here. This is a value. Name, type, width, decimal, label, and value. So in front of sex, in below value, there is none. And please there, and this is a clear cut none. There is nothing else. So what you have to do, you have to click here. This will come here. Okay. So what I have to do, I have to click here, value number 1, and label is a male. I think in less than 29, there is some different structure. I will show that also, no issue. Okay. Then click again, okay. Then click here, 0, and 0 is a female. Okay. So click OK here. And if you have 1, 2, 3, 4, just you have to click plus sign, and if you want to remove, you can click a cross like this. Cross, it goes. Click plus, then again enter 0, and this is a female. Sorry, female. Then click OK. Okay. Then you can see here again, I will like calculate frequency and percentage, and I can see magic of this. Click analyze, descriptive frequency. Please remember this and I can remove this. Click here, then click hypertension, shift and down arrow. Click here, and I want to keep only sex, and then click OK. You can see the difference between earlier it was 0 and 1. Now it's a female and male. So it's very easy. So please do for these also: hypertension, diabetes, smoking. Again, I just give demo for this, no issue. Click your data view, go to data view. Okay, sorry. Okay, then I want to do for hypertension. So if there are two ways. You can click this variable view. Okay, otherwise you can click hypertension, or any column, double click, you direct go to variable view. Again, data view, click this hypertension or gender, click gender, double time, you will go to in gender, sex. Okay, and this is, so here is our hypertension. In front of hypertension, in front of values, click this none here. You can see this, and you have to click plus sign, and we remember that 0 is yes. So no need to remember, because always, there is a mistake. 0 is no. Okay. Click plus, then 1, and here yes. So there is some difference, I think in box or in when command in less than 30 SPSS, I'll send a short video in WhatsApp group, no issue. Then click OK. Then please do for rest of the variables. Then go to analyze, then descriptive, then frequency, now hypertension. This is last thing, okay? Then click OK. So you will get this yes and no. So it's a very interesting thing, okay? So I think, and we will do like t-test and dependent t-test on one ANOVA and their counterpart Mawali Kaika in tomorrow. There is no problem. But these are the basic things we have to do before actual analysis. We have to remove cosmetic and logistic errors, okay? And the use of this freeze pens in Excel sheet and the use of this serial number, because these things make our work very easy. Okay, thank you. If you have any question, you can ask me. And 1 minute, I want to show how to save this, because these are our result. So how to save in Word file, okay? Every time we have to save. So what we have to do, we have to click this below this transform, we have to click this Word, okay? There is a Word, I think, page, and this is a green arrow left side. Click here. This dialog box come, export output, object to export. Please always click all visible. Okay, no need to click all. You can click all, no issue. But I recommend this all visible. There is some reason, but no need to. Then yesterday I have saved as a result. So if I save same, that file will be replaced. So I want to give another name, okay? So what I have to do, I have to click here. Then I have to remove this .docx. Just click one or new. Whatever you want to give name, you can give. Okay. Then click OK. Then click OK. Okay. So give OK. So this is saving to the export file. It will take time because I think today we will do a lot of things. So it will take some more time. We did a lot of things today in analysis, but basic things. Okay, it's saved. I can cross it. Okay, and now I want to save this also. So what I have to do, this is button below edit. There is a button. It is save this document. You can use, otherwise you can go to file, then you can click save or save as, whatever you want to do. But I use this different button here below this edit. Click here, and then it will come SPSS session. Okay, I'll save in SPSS session folder, desktop. I can give name. If you don't want to give name, it means you are lazy person. Otherwise, please give name. Okay. So this is a new data sheet. And please remember one thing. Click OK. Okay. Please click OK. No issue. So you can see this is a new data sheet came here. And please remember, it's a very small thing. Whenever you enter data in Excel or SPSS, every time, please, after entering, for example, you enter 1 patient data, please save it. Don't think after entering all patients or 10 patients, I will save. No, because these are the software, and please don't believe this software. Your data may be lost. Every time you have to save. And number 2, whatever data you enter, please, after saving, email you and your friend. Okay, whatever you want, you can email, but please email. So this is safest method to store your data for a long time. Otherwise, this is a laptop. It is working, but after 1 minute, what happened with laptop, cannot predict. Nobody can predict it. Okay. So please remember, it's my humble request. Otherwise, you will definitely cry because you don't have time. and your guide and co-guide will pressure you, where is data, where is analysis, and because it's like I think their responsibility to go complete your work and publish your work in excellent journals. So it's very good for you also. But please remember, save your data, email your data to you, your friend. Okay, so safest is to you. Okay, yourself, you just email. Thank you, we can cross it. Okay, closing the data editor, yes. Okay, thank you. This is you can see here in my SPSS session there is a new data sheet. Fantastic. Okay, sir.